Okay, so our final section of the year, woo, is about identities. So it's 13.6, the fundamental identities. So recall that earlier, in the last unit, we learned the Pythagorean identity, which says that sine squared plus cosine squared equals 1. Remember that was related to the Pythagorean theorem. Sine is the value of y, cosine is the value of x, so therefore in a unit circle, x squared plus y squared equals 1, right? So this point right here was x comma y, so we went across x, then it's a unit circle, so sine squared plus cosine squared equals 1. Well, if that's true, let's say we rewrite that right here, and let's just say that we divide everything by sine squared. So I divide the first term by sine squared. I divide the second term by sine squared. And I divide the third, or what's on the other side, the third term by sine squared. Well, what happens when I do that division? Now, sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent squared theta. And 1 divided by sine squared, well, that's the reciprocal, right? So that's cosecant squared theta. So because of this Pythagorean identity, we can get two more identities. One is the fact that 1 plus cotangent squared equals cosecant squared. And then if we do that same process, except instead of dividing everything by sine squared, we divide everything by cosine squared, we'll get something a little bit different. So let's see what happens. So now we divide sine squared by cosine squared, that's tangent squared theta. Cosine divided by cosine, cosine squared divided by cosine squared is 1, and then 1 over cosine squared is secant squared. So because of this Pythagorean identity, we now know that these are also true. Because remember, if you divide by the same value, you're going to get the balance of the equation is still remaining. So we're going to use these throughout this lesson, or we might use them, we might not. But certainly you want to refer to them. Okay, other things that you're going to use are the reciprocal identities. So the reciprocal identities are like sine of theta equals 1 over cosecant of theta, or cosecant of theta equals 1 over sine of theta, right? And cosine of theta equals 1 over secant of theta, or secant of theta equals 1 over cosine theta. Tangent, of course, equals 1 over cotan, and cotan equals 1 over tan. And then, of course, not only that, we know that tan equals sine over cosine. So that's what it means by the tangent identity, or cotan equals cosine over sine. So we'll use this information in order to complete these simplifications, or on the back of this page you'll see that we're going to try to prove that one side equals the other side. Okay, so in this first one it's a little more directed for our instructions. It says use the reciprocal identities and Pythagorean identities to simplify the given trigonometric expressions. So whenever you see one of these reciprocal functions, that's assigned to put in the reciprocal. So cosecant is the same as what? Well, that's the same as 1 over sine. Oops, not a minus sign there. And cosine, then I'm going to keep that the same. But then every time you see a cotangent, you might want to switch that into cosine over sine. Right, so I'm replacing cotangent with cosine over sine. I'm replacing cosecant with 1 over sine in order to try the simplification process. Now here's the weird thing that gets tricky. How do you know if the final expression is simplified? Well, I can only say to you that simplification means you should omit the plus and minus signs. You should make it just one simple term. So let's work toward trying to omit this plus or minus sign. So if you notice here, this is cosine over 1, so I have a common denominator of sine for both of these terms, so I can combine the numerators. So it's 1 minus cosine times cosine. Well, what is cosine times cosine? That's cosine squared. Now going back up here to the Pythagorean identity, not only does sine squared plus cosine squared equal 1, but if you isolated sine squared, that would equal 1 minus cosine squared. Or if you isolated cosine squared theta, that would equal 1 minus sine squared theta. And the same is true for these, right? If you isolate tangent squared, well, tangent squared theta equals secant squared theta minus 1. Or cotangent squared theta equals cosecant squared theta minus 1. So you also might use these as part of your Pythagorean identities. Now again, let's look back down here. What do you see? You see a 1 minus cosine squared theta. Well, right here is 1 minus cosine squared theta. So what can I replace 1 minus cosine squared theta with? I can replace that with a sine squared theta. So therefore I get sine squared theta over sine theta, and now sine squared over sine, well, one of them cancels, right? So I just am left with sine theta, or I'll put that down here. So my simplification, so this little complicated expression at the beginning of cosecant theta minus cosine theta cotangent theta just simplifies to sine theta. So this is obviously more simple than what we started with. So let's try letter B. You can pause now and try it on your own, or you can just follow me. There's no reciprocal functions here. Like usually we only reciprocate the cosecant, secant, and cotangent. So I do see tangent here, which leads me to think I'm going to have to change that to sine over cosine. Okay, now tangent's being multiplied by sine, so I'm going to multiply that by sine over 1. Well, this is a fraction that has a denominator of cosine. This is not a fraction, which means it has a denominator of 1. Whenever you have something in fraction form, you have to get a common denominator. So if I want to get a common denominator, my common denominator is going to be cosine theta. So this first fraction is missing that common denominator. So I have to multiply the numerator and denominator by cosine theta, which then changes this to cosine squared theta. Cosine times cosine is cosine squared theta. I have a common denominator of cosine. This is just sine times sine, which is sine squared theta. Right, I have my plus sign here that my little cosine is overlapping. But here, I didn't do anything to this, I just simplified it. Sine times sine is sine squared, and it's over cosine. Now, what do you see? I'm hoping you immediately see the Pythagorean identity. Cosine squared plus sine squared equals 1. So now I'm going to replace that numerator with 1. And then 1 over cosine, my final step, well, that's a reciprocal function, and that's the same as secant theta. So this thing is just as simple as saying secant theta. And you are done. Okay, this last one, let's rewrite secant theta in terms of sine. Okay, well, the only thing I know to do with secant is to make it a reciprocal of cosine, and we saw that right here. That secant is the same as 1 over cosine theta. Okay, if I'm trying to write it in terms of sine, then I have to tie cosine to sine somehow. Well, we know up there from above in the Pythagorean identity that sine squared plus cosine squared theta equals 1. Well, if I'm trying to get it in terms of cosine, I'm going to isolate cosine squared, which equals 1 minus sine squared. My last step is to then take the square root of both sides. But remember, when you take the square root of both sides, you get plus and minus the square root of 1 minus sine squared theta. So now I have a singular cosine to the first power of theta. Here, by taking the square root, I got a singular cosine to the first power of theta, and that equals plus or minus the square root of 1 minus sine squared theta. So this then, in terms of sine, is 1 over plus or minus the square root of 1 minus sine squared theta. So that is how you would write secant in terms of sine. Secant of theta equals 1 over plus or minus the square root of 1 minus sine squared theta. So in your calculator, whatever this angle is, if you wanted to make these two things equivalent, you'd have to do this. Okay, moving on. So those I would say are the easier ones. This back gets a little more complicated, and what you'll find is that they're like little mini puzzles. And with a puzzle, you either see the pieces and they fit together perfectly and it's awesome, or you have to try a few and work it out. So some of you are just going to connect with this right away. It's not going to be a problem, and you're going to go through it, and it's going to be probably relatively easy. Others of you, you're going to try something, it's not going to work, you're going to start over, try again, it's not going to work. So there's a variety of ways to do this simplification process. There's a variety of ways to make one side equal the other side. So it's kind of a pain for me to grade because I have to go through and see your ways, but on the other hand, it kind of leaves you some space. Don't think the way I show you is the only way to do it, because a lot of times in math, that's not true. We teachers teach you the way that we think is easiest, but that's easiest for us, not necessarily easiest for you. Okay, so tips for proving identities. Again, these are just tips. So work with more complicated side of the identity to obtain the easier side. So this is huge. It's way easier to try to make this simple than it is to try to unpack this simple thing into looking like 3 terms added together. So you always want to work with the more complicated side. Now in some cases, it's hard to tell what the more complicated side is. Okay, the second thing, substitute one or more basic trigonometric identities to obtain simpler expressions. Factor and multiply. Look for expressions equal to 1. That's your sine squared plus cosine squared stuff. Or your tangent when you replace the other ones with tangent and cotangent, secant, cosecant. Express all trigonometric functions in terms of sine and cosine. That's true. Read through these strategies. So there you go. So we have left side, right side. So the equal sign separates. This is my left side, this is my right side. So the first thing I'm going to do, I'm going to take tangent squared. Am I going to change it to a cosine squared? I could, or sorry, sine squared over cosine squared. I could. Or I might first just take this and see that's a reciprocal function. And what is the reciprocal of 1 over cosecant squared? Well, that is sine squared. And so sine squared, right there, immediately, I hope that whenever you see sine squared plus cosine squared, you immediately see this as just replacing the number 1 in there. Right, so this becomes a 1. So my next line is tangent squared theta plus 1 equals secant squared theta. So notice I'm writing the same thing every time. Now because, remember at the beginning, this trig identity right here, when we divide everything by cosine squared, we get tangent squared plus 1 equals secant squared. So because of that trig identity, we then know that yes, this secant squared, that equals secant squared, this equals secant squared, so you're done. Or your other option would be once again to go sine squared theta divided by cosine squared theta plus, well how does this 1? The 1 you'd have to change it into a common denominator of cosine squared plus cosine squared. And then you would say 1 over cosine squared theta because sine squared plus cosine squared equals 1. And then you get it down to secant squared equals secant squared. But that was just extra work when you could have jumped right to here because of the Pythagorean identity. Okay, let's look at letter B. Again, to me, for sure, the left-hand side is way more complicated because you actually have a fraction, you have addition, so let's leave the cotangent squared alone. So on the left-hand side, well, I see this 1 plus cotangent squared theta. Is that one of my Pythagorean identities? It sure is. 1 plus cotangent squared theta equals cosecant squared theta. So I'm going to immediately replace the numerator with cosecant squared theta, and then that's divided by secant squared theta. Now these are both reciprocal functions. Cosecant is 1 over sine squared, and secant is 1 over cosine squared. So some of you might have just combined these steps, and you could have multiplied by the reciprocal of the denominator, right? So this, we turn it upside down and multiply, right? When you're dividing a fraction by a fraction, turn it upside down, multiply. So continuing down here below, you would get cosine squared theta divided by sine squared theta. And then, of course, cosine squared theta divided by sine squared theta is equal to cotangent squared theta. So you get cotangent squared theta equals cotangent squared theta, and you're finally done. So you need to be neat in your presentation and show all the work in steps that are very clear. Next video.